Hello, subatomic ducklings. Today, I'm going to teach you guys integration. Now, what is integration, you might ask? Integration is an area of calculus that deals with finding the area under the curve. So that's the area between a function and the x-axis. Now, when you're typically dealing with areas, you usually think of the shapes, such as the ones in front of you right now, the square, triangles, circles, etc. Now, they have pretty easy areas to calculate. As you can see in front, the area of a square is just length times width, area of triangle half length times width, and the area of a circle pi r squared, which I will explain in future videos. But as you can see, all these shapes have very simple areas, easy to calculate. Now, what happens when you have something a little bit more complex? Now, not everything in real life is straight shapes like squares and circles. Sometimes you get something a little bit more complicated, like this function f of x. How would one find the area under the curve of this function? Now, one way we can deal with this is to get an approximate of the area through rectangles. Now, we can draw rectangles as such. Now, this will give you a decent approximation of the area under the curve. Now, as you can see, you miss a couple of spots, like this big one and this big one. But regardless, it'll give you an approximate area. Now, you would calculate the area, this approximate area under the curve, by getting the areas of each individual rectangle and adding them up. The area of a rectangle can be gotten through its width times the length. Now, in this case, the width is simply the change in x, and the length will just be the f of x value for that specific x value. To get the total area under the curve, you would just add them all up. So the summation of f of x times delta x. And that is how you would get the area under this curve, or rather an approximation of the area under this curve. Okay, so now I have a function, the same function as before, except now the width of the rectangles is less than before. Now what you might realize is that the smaller the width of the rectangle, the more accurate the approximation of the area under the curve is. Okay, so since decreasing the width of the rectangles gives us a better approximation for the area under the curve, let's make the width of the rectangles infinitely small. Now what does that mean? That means that the width of the rectangle should be approaching, the limit for the width of the rectangle should be approaching 0. Not equaling 0, but just ever so slightly close to 0. Now that'll look like this. See, it's the same thing as before. It's a summation of all the areas of the rectangles, f of x being the height of the rectangle at every given point of x, and delta x being the width of the rectangle. Now the limit as delta x approaches 0 for x will give you a value of dx, and you might recognize this from differentiation. It is a similar concept in integration. So this can be evaluated to give the integral of f of x dx. Now essentially what this is, it is just the summation of all the infinitely small delta x values, in other words the width of the rectangles, multiplied by the height of those rectangles, which is the y values at that point, or f of x. Now don't get bothered by this symbol over here, that is just the integration sign. So now that we understand the basic concepts of integration, let us try a question. Here we have a function f of x equals x squared. Now, what is the integral of x squared? How do you get the integral of x squared? Well, to do this, you have to understand that integration is basically the opposite of differentiation. The operations that you perform is basically the opposite of differentiation. And to show you what I mean, here we have a general function in the form of ax to the n. Now, what happens when you take the derivative of ax to the n? This is just the power rule. When applied, you get n times a times x to the power of n minus 1. Pretty basic. You basically multiply the value of the exponent and subtract 1 from the exponent, whereas the constant a remains the same. Now, integration is the opposite of that. So if you integrate a function ax to the n dx, then you will get ax to the n plus 1. So instead of subtracting 1, you add 1. And then you divide by that value, n plus 1. Notice how you divide by n plus 1, not n. So basically in differentiation, you multiply by the exponent first and then subtract 1. Integration is the opposite. You have to start with the exponent, add 1, and then divide. So using this, we can now solve the equation for we can solve the expression, the integral of x squared dx. So by using this inverse power rule, we can get that the integral of x squared dx is x cubed over 3. Now an important thing that you will have to do is add a plus c like this. Now plus c just represents a constant, and you have to do it when you have an integral such as this, and I'll explain this plus c in later videos. But that's all you need to know for the basics of integration. Now you know the concepts of integration, how to visualize it, and how to integrate basic functions such as x squared, x cubed, basic polynomials as such.